Welcome friends, Igor is here, and in this video we will talk about injective linear transformations. In this lesson we will define injective linear transformations and learn how to check if a given linear transformation is injective. Let's get started. A linear transformation is called injective, or an alternative terminology is one-to-one if it is injective as a function. This means if t of x is equal to t of y, then x must be equal to y. The contrapositive of this statement is if x is not equal to y, then t of x is not equal to t of y. And we can interpret this definition as follows. Injective linear transformation sends distinct inputs to distinct outputs. Let's look at an example of a linear transformation from C2 to C2. Let x be the vector 1, 0 and y be the vector 1, 1. Then the value of t at the vector x is the vector 1, 0 and the value of t at the vector y is the vector 1, 0. So we have two distinct inputs, but the values are the same. This means that this linear transformation is not injective. Let's consider another example. We have a linear transformation T from the vector space of polynomials of degree at most 3 into the vector space of matrices of size 2 by 2. Let's check that this linear transformation is injective. For this, we are going to use the definition. We are going to assume that the values of the linear transformation T on two inputs are the same. In this case, the inputs are polynomials. And we will show that this forces the inputs, the polynomials themselves, to be equal to each other. This is an equality in the codomain, so this is the equality of 2 by 2 matrices. We can rewrite this equality as follows. The difference of these two matrices is equal to the zero matrix. But T is a linear transformation, so it respects addition of vectors. We know how to subtract two polynomials, and we know what T does to any polynomial. So we get this equality of two matrices. But two matrices are equal to each other if and only if they have identical entries. And all entries of the zero matrix are equal to 0. This is a homogeneous linear system, and let's think of the differences as the unknowns in this system. We can represent this linear system in the matrix form, and we can check that the coefficient matrix of this linear system is non-singular. This means the linear system has only the trivial solution when all unknowns are equal to 0, but in turn it means the equality of the input polynomials. So we assumed that the linear transformation T has the same value on two input polynomials, and we were able to show that this forces the two input polynomials to be equal to each other. This is exactly what it means for the linear transformation T to be injective. If you found this video useful, please give it a like to help others discover this content, and subscribe to this channel to see more of these videos. In the next video in this series, we will discuss the kernel of a linear transformation and how it relates to injective linear transformations. I will see you later.